So, today actually we are planning to discuss about the image sharpening, which is one of the important features or image processing or image operations, which will be needing very frequently for biometrics. This is a system design. Okay. So, the sharpening is also one kind of filtering technique, and it is also you can achieve through convolution. What is your aim? Aim is that you have the finer details in the image, those finer details you want to sharpen. This is a thing. You want to make it more bright, you want to make it more highlight and so on. Or there may be some area where due to some reasons it has become blurred, you want to highlight it or you want to enhance that blurred part. Okay. Now, this blur can occur because of the natural effect. What does it mean? That you have used one camera and that camera is giving you the image with the blurring, with a smooth effect, right, smoothened one, but which gives you the soft look of on the image, but that may not be helpful. You want to highlight the component which is say road, I want to highlight the road component, right. So, or because of some image processing operations you perform on the image and due to that you got the blur. Okay. Say for example, we have considered already that average filtering technique. It takes the neighboring pixels to replace the central pixel, and as a result it creates the blurred image, right. So, average is nothing but sum of neighboring pixel divided by the total weights, and obviously this is a analog towards your integration, right. So, you want to deep blur the things, that means you want to perform the reverse operations. That means you need to do something similar to differentiation, which will give you the sharp image, sharp component. Am I right? So, that is your aim. That means you need to know what is the behavior of the derivative. Now, consider the gray values of say one row. So, maybe it is like that 10, 10, 10, 10, then maybe 15, 17, 20, 23, 25, and then continuously it is 25, 25, 25 and so on. This is the gray values or intensity values of a row in an image. What it gives? That if I see that, if I plot it here, it will go like this 10, 10, 10, 15, 20, 17, 23, 25 like this. Am I right? So, what is the behavior here if I think about the derivatives? What is the behavior here or here at this points? This is the discontinuity point here, right, or this is here. What is the behavior if I think about the derivatives, or what will be the behavior in this area where it is increased, the ramp is there. These are the derivative will give you some information about this structure. Now, this type of situation will occur when there is a little noise, maybe there is an edge, maybe there is a line in between and so on. So, this is the scenario. So, ideal digital image, if I want to get a sharp line, then I should have got from black to white straightway, then you will be getting the sharp line. This is the ideal scenario, that if I want a line here, a sharp change between these two, then there should be sudden change 0 to 1 or 0 to 55. It cannot be 0, 0, 0, 0, then 17, 19, 20, 30 and so on and finally 255. This is the ideal scenario, but in reality you will find that it is not sharp change, it is not sudden change, it comes slowly changing and so on. So, this slow change may be because of your camera, because of the optics, because of your image operations you perform on it, right. And this is your RAM component. Now, this RAM component plays an important role to understand the sharp image or not sharp image, right. So, you observe that if I take the first derivative on the constant values, there is no change. So, you will get the first derivative with 0, right. Here at this point first derivative or at this point the first derivative will give you the non-zero, and when it is on the ramp there also you will get the first derivative non-zero elements. So, when it is constant, intensity value is constant, the first derivative will give you the 0 values. When at the onset of the gray level step or ramp, just here you will get the non-zero values in the first derivative, and also here also you will get the first derivative 0. But this is not the case with the second derivative. When the constant intensity level change in the level change is constant, you will get the 0. When it is here the second derivative also you will get 0, but at these 2 points you will not get 0. Now, this slope of the ramp will help you to understand the degree of blur, right. See, if it is a sharp one, if it is the sharp one, that constant gray values here, and after the sudden change and you got the gray values like this, right, the slope will be what? Slope will be 90 degree, right, and the slope is more and degree of blurring effect will be less. So, they are inversely related. Is it clear? So, as I told you that in reality you will not get this type of thing, you will get this type of thing, right. So, if the image is sharp, then you will get only 1 pixel jump, right, that intensity level is 0, 0, 0, 0 and then suddenly 255, 255, 255. But it will not be 1 pixel jump, it will get several such pixels, slowly it is going up, right. So, we no longer have a thin path. Instead, what you will be getting? You will be getting an edge point on this ramp, that any point on the ramp will give you an edge point. Now, edge will be giving you that you can tell this is an edge when you have several such points which are connected. That will give you an edge, otherwise it will be a noise. Just one point and just jump, it is a noise, right. Now, what is the thickness of your edge? Because as I told you that if it is a sudden jump, then there is 1 pixel difference, the thickness is single pixel. Otherwise, if it is of this ramp type, then thickness of the edge is the length of this ramp. Now, this length will be increased as the angle is small, that slope is very less. If the slope is very less, then angle will be, this length will be more, am I right? Length will be more. So, length will be dependent on the slope, and this length will be less, this length will be less when it is thickness is less. So, edge thickness is dependent on the slope of the image, slope of the ramp, and that means that edge thickness is dependent on the length of the ramp, or can I draw down further that edge thickness will give you the degree of blurriness, because as I told you that as the slope is less, blurring effect is more. So, this length will tell you the how much blurred it is, am I right? So, edge thickness will give you the degree of blurriness, agreed. So, if you have an edge, this thickness is like that, that means the blurring effect is more, right. So, blurred edges tend to be thick, while sharp edges tend to be thin. Remember, in the case of the problem is, I want to get the sharp image. I want to get the sharp image means I want to get the sharp area on the details where you want to attack. You want to see the railway line, right, or you want to see the airport. So, boundary of the airport should be sharp enough so that you can understand that this is an airport. Now, as you know, in the case of, because you cannot think about the continuous domain, it should be on the discrete domain. The first order derivative is del f by del x, and which is f x plus 1 minus f x, right. And if I go for the second order derivative along the x, del square x by del x square, and if I proceed like that, then you will get f of x plus 1 minus 2 f x plus f of x minus 1, right. So, this is along the x axis. Similarly, you can think about along the y axis. Now, if you analyze this one, that what we have seen, the first order derivative will give you the non-zero from here to here, non-zero coefficient, non-zero values. But this is not the case with the second order derivative, it will give you the non-zero at this point only. This is the thing what we understood. So, what you will get is the second derivative, first derivative case, if you see, this is your original image, and if you see the first derivative case, you will get the result like this. But if I take the second derivative, only the non-zero values will be coming here and here, wherever there is a change, otherwise all of them are zeros. Am I right? So, in the second derivative case, it produces the two values. I will check, that diagram will help you to understand, I will do that. Second derivative produces the two values for every edge in the image, right. Now, if I think about a line connecting these 2 points, this will cross the zero area, and this is known as zero crossing. We will be using very frequently this term. This is the zero crossing property. Now, this zero crossing property will help you to understand or to get you the estimated center point of the thick line, thick edge. Okay. So, this helps you that once my thick line is like the thick edge is like that, I can estimate the center of this center point of the thick image, because that is required if I want to obtain a thin image out of the thin edge out of the thick edge. This is one example. This is your original image, this is the first derivative one, and then this is the second derivative one. So, this is the thing I was talking about. This is the original ramp, and the first derivative will look like this, second derivative for this case is coming like this. Now, we added some Gaussian noise, random Gaussian noise with mean 0 or sigma this, then image will look like this, and the first derivative will be of this order type, and the second derivative grave level profile will be like this. And this is the case with different types of noises. After adding different types of Gaussian noises, you will be getting like that. So, what you observe that if I add simple noise into that very small quantity of noise, it is creating a havoc on your first derivative and second derivative, right. See, by adding small noise, see the first derivative and second derivative structure. So, it creates a problem for you. So, if there is a little noise or some salt and pepper noise on your image, that first derivative and second derivative may not give you the good indications or about your non-zero components. So, what is suggested that if you first smooth the image by some method before you think about the derivatives, right. So, first you smooth the image by some method, say average filtering is also there, or any method. Once you do it, that noise will be gone, then you perform your the first derivative or second derivative. Now, this Laplacian filter, it is a second order derivative. The simplest isotropic derivative operator is given by del square f del x square by del square f by del y square. So, isotropic means that it keeps the property along both the directions and along all the directions basically, right, x directions and y directions. So, that is the thing what we have taken this derivative and also with respect to y. If we look into that del square f by del x square, you will be getting this one, right. These are the 3 points, so I have to compute this one. So, from the derivative, second derivative, we got this formula. That means, this one plus this one minus 2i's of this one. Now, if I have follow along the y directions, then this one plus this one minus 2i's of this one, that will give you the second order derivative along the y, right. So, if you remember the formula is nothing but the sum of these two, So, if I combine this, the del square f by del x square plus del square f by del y square, you will be getting that f of x plus 1 y plus f of x minus 1 y plus f of x y plus 1 plus f of x y minus 1 minus 4 times of f x y, and this I can write as my kernel 0 1 0 1 minus 4 0 minus 4 1 and then 0 1 0. Am I right? Yes. So, this is the kernel. You will be moving from the left top corner to the right bottommost points. Now, if you observe, this kernel was taking care x directions and vertical and horizontally. I could have thought that no, I want to give the importance on the diagonal. So, this gives you the diagonals. If I add both of them, then I will get all 8 directions, right. So, the kernel becomes 1 1 1, 1 minus 8 1, 1 1 1. That kernel gives you that whatever second derivative you got, right, along the x direction and along the y directions. So, if I subtract that one from the original image, that one from the original image, I will get the sharpened image, right. That to get the sharpened component, that second derivative you will be subtracting from the original image. Now, this subtraction is coming when the central pixel is central kernel value coefficient is minus. If it is a plus 1, that means you have to add. The sharpened image is nothing but f of x y minus del square f x y, when the central pixel or central coefficient is negative. When central coefficient is positive, then it is f of x y plus del square f x y. So, if now you know the formula, you know the value of this, right, that is nothing but f of x minus 1 y plus f of x plus 1 y, that formula is known. If I put it, if we put this value, that f of x y minus this, if I put this value, I will get this value. Am I right? With minus del square formula, if I put this in minus formula and combining this, I will get this 5 of f x y minus this. So, this gives you the kernel of this form, right. So, this has come from this formula that I have just put the value of del square f x y here, then you will get the equation 5 of f x y formula. Same is the case if you put this one here. So, you get 0 minus 1 0 minus 1 5 minus 1 0 minus 1 0. Now, suppose I want to add the I want all 8 directions, then obviously this kernel has to be added along with this. So, finally, we will be getting minus 1 minus 1 minus 1 9 minus 1 minus 1 minus 1 minus 1. You could have thought no, this or this is minus, these are all plus. So, the reverse one you will be getting. Okay. So, one thing you remember that this sum of all the coefficients is giving you the value 1. What it gives you the idea that brightness is retained, average brightness of the image will be retained, right. That is from the definition whatever we have discussed earlier. Agreed? Now, this was one example I took, that this is the original image of Mars, and then you have put this kernel and you get the g value of derivative ones, filtered Laplacian filtered values. So, what you do basically, first you obtain you perform the Laplacian of filter on the image, and then you will be adding that value or that filtered image with the original image to get the sharp image. Okay. Now, if you see the reverse one, I need to find out. I want to get the sharpened, I want to get the sharpened image, that is the whatever of Laplacian filter component you got, I want to get it from the image f x y. So, original image f x y is given to you, and if I subtract the blur component, that should give me the sharp image or not, that you have the original image, the blurring part I want to subtract from it, I should get the sharp image. Yes, see from the definition itself, it is there where I wrote the g x y. So, g x y is equals to f of x y minus the filtered image. So, I need to get this filtered image. So, what I will be doing, that f x 1 minus f x y minus g x y will give me this. G x y is your sharp image. So, unsharp it, if I have to unsharp it, just I have to subtract g x y from f x y. What is g x y? G x y is a blurred image. So, the blurred image, if I subtract from the original image, I should get the sharpened image. So, how to get the blurred image? Blurred image, one way could be that you take the average of the neighboring pixel, right, or in natural you got the blur image through your camera. That camera is always giving you a blurred image. That blurred image and original blurred image, whatever you have after performing the pre-processing operations, you just subtract it, you will be getting the sharpened component. So, if I know this fxy minus f bar xy, that if I subtract that blurred image from fxy, what are you going to get? Say, I have the face image, right, and I have taken the under one is that control environment, another one is that under different illumination effect, right. Now, the different illumination one or illuminated one, you have taken the average of, you obtain the average image. Then if I subtract it from the control environment, what you will be getting? That illuminated effect will be gone. Is it okay? I have the illumination image and I am subtracting the average image, then illumination effect will be gone, right? Reflection parameter will be eliminated, right? Yes. So, that is the thing we need to do. What we do in the palm image, given original palm image, and then I obtain the average image of this. Say, I have the palm image here, and I divide into the several blocks. I obtain the average of this, all the values, I put it here, average of these values, put it here. So, I obtain the average of each block. Average of these blocks. Now, this average I replicate on all whole sub blocks. So, this average is here. This average is here, right. This block consisting of the average intensity value of this block. Now, if I subtract this one from the original image, what you are going to get? That whatever extra things is there, that will be eliminated. You will be getting the true value. Now, one problem you will be facing, if you think this way, that if I subtract the average value from the original value, there is a possibility that some will become the negative values and some will be the positive values. Am I right? And also the values may be very less. If I subtract the average value from the average value of the block from every intensity value of that block, you may find the values will maybe some of them may be negative and some of them may be positive, and the range of the values may be very less. And as a result, what will happen? That image will become very dull and dark, it will be a dark image, right. Or since the negative value is there, an 8-bit negative value, because I am assuming that this is an INT in form. So, it may give you very sharp, very white color. So, what is the best method? Before you look for the image or before you like to see that one, you first find out the minimum and maximum, and then we discuss how to stretch it, we make it 0 to 255 range. Then image become the usual normal image after subtracting the illumination parameter or reflection parameter, right. Say this in the case of palm, it becomes very useful, because if you see that palm, that some part of the palm is not flat, they are little oval shape, right. So, you may not get the good illumination free images. So, the idea is that by seeing the image, especially you will find when you are taking the photographs in the non-control environment. See, our problem, whatever image we have in our lab, they are all under control environment. But in the anywhere, nobody will accept research component. If I forget about the research part, but if I have to tell that we have developed something, they will not tell you that, okay, this is a control environment, give me the data, and then I will go for committing crime, and then I will come and give my data again under control environment, and then you match it. But this is not the in real life. Real life is that you don't know where from you will be getting the data and who collects the data. You cannot give the instruction that yes, you have to get the data under this condition. The person who is collecting the data, he may not know also how to collect the data. He has been asked to collect the data, he is collecting the data, right. Say for example, I can give you one example here, that if you go to the Thana is the police area, once they get the culprit or suspected culprit, they take the photographs, right. And these photographs, they keep it in such a first thing that they don't know how to collect their photo. They are supposed to take the photograph, they collect the photograph, just take the front face, side face, and they put it in the notice board with a stamp. Now, they put the stamp in such places where that the whole image is gone basically. It is useless for us to evaluate or to match with another photograph, because the stamp may be on the whole face. Now, how to remove the noise from that whole face itself, because if you remove the stamp from the whole face, then maybe some important properties also will be missing or will be eliminating. And in the court of law, they will tell that yes, you have spoiled the image, how can you tell that this is the same person? So, same thing happens if you see that your, I do not know nowadays whether they put the stamp on your iCard or not. So, the person who puts the stamp on iCard, he does not care where to put the stamp, he puts the stamp, it may be on your whole face, right, and it may not be useful at all later on to identify whether he is the man or not. So, this under control, and we are thinking that the image will be under control environment, it is not the case. So, when you go to the field, real field, you have to eliminate some things. So, you have to perform the operations, sharpening operations, so that you can eliminate some of the such factors. Say for example, I take your photograph, fingerprints, after taking the lunch, suppose I collect your, I am assuming now you are using hand to take your food. Then soon after your lunch, I want to take your fingerprint data. What will happen? Irrespective of how much quantity of soap you use to clean your hand, but oily stuff will be there on your hand, right? And that creates the problem on my scanner. You give the data, first thing is that it will smudge. Your data will be smudged, that whatever reach value, they will be smudged. Second component is that you have given your data, you have left. Now, the second person has come, his hand is also oily thing, greasy materials are there, and he has put it. And you have also kept greasy intensity things on the, because I have not cleaned it also properly. So, those will create some false images on my original data. So, right, this is the real scenario. So, you have to see, or you have to remove those false image lines, right. One thing is sure, that whatever you will be giving and whatever your predecessor has given you, there is a difference. Your thing will be more sharp compared to the predecessor, because he has already left and he has his thing, the person concerned, he will be removing, he will try to remove, but then also the symbol is there, so the signal will be there, right. So, you have to sharp your image accordingly. So, this if you see, remember that if you have the image where your fingerprint is here and lines are here, and there are some lines which are in light or low intensity, lines will be there. So, this average, or if you do the smoothing operations, you will find that this will be gone, because this will become the noise and this will be eliminated through mean filtering or average filtering. Now, why to put only the original image fxy? What I want, that I first boost it, that fxy, by some constant, right? Then you subtract the blurred one. So, what I am telling, that multiplying by some constant which is greater than 1 with the original image, then I am subtracting. That is the thing I told, that what I did, if I do not multiply it, then there is a possibility the value will come down very small, and some of them will be negative, some of them will be positive. So, all sorts of things will be there. So, instead of doing that, I multiply it by some factor, then I am subtracting the average one. So, if I can rewrite it a minus 1 plus fxy plus fxy minus f bar xy. Now, this fxy minus f bar xy will be giving you the sharpened image, because that is the formula we got from the previous slide, fxy minus f bar xy. So, you get a minus 1 fxy plus the sharpened component. So, this selection of a is important, right? You have to select a in such a way that range maintains, that no one gets negative value and the widespread intensity levels are there. So, if I put in terms of Laplacian filter, then it is nothing but a times fxy minus this Laplacian filter, right, and which kernel wise it is 0, because this is a Laplacian filter, and this is a plus, because it is a minus 1. So, a plus 4, and these are the same thing as it was, 0 minus 1 0 minus 1 a plus 4 minus 1 0 minus 1 0. If I consider the diagonal, then this will become 0, this will become 0, this will become 0, this will become 0, this will become minus 1, this is minus 1 and minus 1, right. And if I consider 8 directions, then you will be getting minus 1 minus 1 minus 1 minus 1 a plus 8 minus 1 minus 1 minus 1 minus 1. So, now what is the best value of a, right? The best value of a should be what? Tell me now, any idea? If a is equals to 1, then it is the same thing you are doing, right? Only thing is that after subtracting, there is a possibility of some negative value and positive. So, that your aim should be such that you, by seeing the image, you have to see that what is your f bar, what is your average things. Now, average thing is almost similar to your original one, then the question of a should be increasing. If average is very less, then a can be written as it is, because small value we are subtracting from the original one, that is not a big thing, right. So, you have to understand this average of these values, that is important. You have the finer details, you want to highlight the finer, that is your aim, or if there is a blurred one, you want to highlight that blurred effect, and blurring comes from these two. One is due to some error or due to some natural effect, or that because of some image processing operations. And so, sharpening depends on the derivative, because it is a blurring is the outcome of the averaging. Averaging is nothing but the integration, that is whatever we have discussed. So, based on how to obtain the derivatives and what is the impact using second derivative, and also we told that Laplacian operators and use of Laplacian operator or filter to sharp the image or high boost filtering techniques. This is edge detection. obviously that by telling that term age is nothing but that what is the boundary of an object, where it has changes intensity a little sharply, right. Now, the definition of sharp is coming, because by now you know sharp change may be there, may not be there, because of blurring effect, right, because of thickness of the edge. You may not realize thickness of the edge means that the intensity value suddenly changing, right, slowly changing, then you may not visualize that this is an edge. So, you have to sharpen the image to get or to realize that it is an edge. And of course, this edge detection technique is one of the fundamental techniques, or this problem is detecting an edge problem itself is a challenging one. Edges are the areas with strong intensity contrast, and jump in intensity from one pixel to that next gives you the edge. Now, once I detect the edge, what happens? Then I do not need to keep the whole image. I need to keep the edge of the image, right. Suppose I have a house, something like that. I do not know whether it is house or not, but assume that this is house and this is tree and some birds are there. Now, by seeing this also you can tell it is a house. I have not given the color, I have not given other shape, only I have drawn some lines, right. So, these are edges, and if I keep these edges, it is sufficient for you to understand the image content. You do not need to, you need to keep all the information of whatever you see in an image. And as a result, if I assume that it is a binary image 0 and 1, and wherever the edge is there I put 1, rest of the things I put 0, then it is a bit vector only, image size will be reduced like anything. And it filters out useless informations, right. Whether there is a seepage in my house or not, you will not be able to say, or shade is there or not, those things are not. So, these are not required to understand the image. However, it retains the structural property, it retains the structural property, right. Now, suppose is it possible to get back my colored image again from there? Is possible color image of my choice. Because those, suppose if I put some pseudo color, because if you remember in my one lecture I have shown you some pseudo colored image with tree and other things. So, that we got an edge and then we put some color, red RGB colors, and then we combine it to show you the color. So, if I put, I know little knowledge is also I know that this is green. So, I will put green, this a little brown color, and this area I will put black, this I will put some combination of colors, and you can see the house. Maybe it will give you the better look than your original house, right. So, it will preserve the important structural properties, but you may not get back your original look of the image. So, what is our goal? Our goal is to extract a line drawing representation from an image. So, it keeps the shape information only, and the shape is, it is invariance. If I reduce the size, then also you will get the same shape. If I increase it, I should get. So, if I have an edge and I increase it, same shape will be there, right. It is invariance to the right. Now, why do you need the edge detection. First one is, as we told, that it will reduce my size and it will retain my structural properties, and so it gives me the outlines of the image. It helps me to enhance the edges. Suppose I get the structural property or then I want to first enhance this image and then I superimpose on my original image, you will find that it looks better. So, the output of an edge detector can be added back to the original image to enhance the edges, right. Once I know this, I will put say 255 values on this, just I superimpose on it. So, these edges will be shown, that the intensity value will give you 255, and so you can enhance it. Second one is very useful to segment something. It is very useful to segment the house from my image. I want to segment this part, only house part. So, for example, I have the fingerprints, 4 finger data you have taken, and I want to extract the point finger, middle finger, thumb, ring finger and little finger from my 4th lap image data. So, how to do it? So, first part is that you have to draw the, or you have to obtain the edge, and from that edge you get the top of the fingers. Now, once you know the top of the fingers, then you will get the, other than the noise, you will get the 4 top, and those 4 tops will indicate that these are your finger area. From there you draw the lines and then you can extract the, because once you get the edge of the fingers, so you get the top of this. So, this 4 fingertips is known to you and this edge is known to you. So, you can extract this copper, right. Segmentation, you can segment the fingers. The third one is most important one, is that image registration. So, suppose you have the 2 images and you want to register these 2. Register means that you want to superimpose one on the another one. How to do it? So, for example, I have one image, say medical image and brain image you have, and through MRI data, MRI image you got one brain image, another one may be CT scan or PET image. So, you want to superimpose on each. One you have taken at time t, another one is at time at t2. Now, in order to superimpose, you have to know that you have to match one by, because you know it is not guaranteed that both the image are of the same area, but exactly same thing. There is a little shift may be there. You have to superimpose means you need to know some texture component. Suppose I know this is texture, this is another texture. So, so this point should map to this point should map to this, then only you can superimpose on it, right. Or you have the satellite image, one path is like this. So, you get the satellite image, frames are like this, another path is like this. This is the frames. Now, I want to get the larger image. So, you got a frame and you got another frame, they are overlapped. Now, you have to register so that you get the bigger image, bigger frame. Is it okay? So, in order to do that, you need to know some critical points. Those critical points should be mapped with the 2 frames and then you can set accordingly. So, that is known as image registration. So, there are 3 factors the edge detection will help you. One is the image enhancement, right. So, what you do, that edge, detected edge, you first improve the intensity value, then you superimpose on the original one, you will find that edge will be very good, fully enhanced. Then image segmentation, they have that if you want to segment the certain features or some certain component from the image, then segmentation will help you. And finally, the two images you want to register, that edge will help you to do that. So, this is the thing I discussed, that in ideal scenario the edge should be sharpened one, but in reality it is not. You will find that there is a ramp, and ramp may be due to the poor quality of scanner, may be due to the image acquisition technique, or may be due to the averaging and other image processing operations.